The sun's magnetic field has flipped, and we are now in the solar maximum, a phase that could lead to significant changes. The sun is unleashing storms more intense than ever before, sparking growing concerns on Earth that a catastrophic solar storm might damage our satellites. Space entrepreneurs, such as Elon Musk, are bracing for the worst, while NASA has been issuing near-daily warnings about emerging threats from the sun. In recent months, we've encountered an unprecedented number of severe solar storms. It's the year 2024, and we're approaching the solar maximum. Experts don't anticipate the sun's most intense activity until 2025. With some satellites already reaching their operational limits, 2025 could hold some unexpected events. In the summer of 2024, Elon Musk shared images showing the stress curves of his Starlink satellites, expressing concern. The newly launched satellite network had just managed to endure the sun's intense bombardment. But what's to come next? Scientists are forecasting that 2025 will mark the peak of the current solar cycle. One of the predictions is a terrifying storm that could lead to catastrophic consequences. We've now entered the solar maximum, and the intensity is unprecedented. The sun's activity has reached such a level that severe storms are occurring nearly every week. NASA has confirmed the reversal of the sun's magnetic field, a phenomenon that isn't unheard of, but it's happening within an 11-year cycle rather than the typical 22.5 years. This shift in the poles is causing violent disturbances in the sun's lower layers. The current solar cycle is called Solar Cycle 25, and it brings particularly intense movements on the surface of the sun. On May 1, 2024, a strangely large sunspot region appeared, which was given the name Active Region 3664. This sunspot grew to 17 times the size of the Earth in just a few days. The spot was created as a result of the internal upheavals. The spots appear darker to us than the rest of the sun. This is due to cooling in the areas of the spots. In the lower part, a kind of cavity is created by powerful currents and layers collapse. A small indentation appears, which is cooler than the surrounding area. This phenomenon is often linked to intense solar flares and coronal mass ejections. During these events, vast amounts of charged particles are released from the sun's surface and directed towards Earth by powerful currents. When these particles collide with Earth's magnetic field, they gather at the poles. Earth has a remarkable defense mechanism, functioning like collection bags that trap particles within the layers of our atmosphere. These particles are tossed back and forth until they lose their charge. The result of this interaction is the stunning auroras we witness. Typically, these brilliant lights are confined to the polar regions, but this year everything has shifted, and we've seen auroras in areas where they don't usually occur. A geomagnetic storm, one of the most powerful in the past 500 years, produced stunning auroras visible as far as the Mediterranean, Australia, and Hawaii. NASA is concerned about an impending solar flare, the most intense in 7 years. Experts at NASA are worried about the safety of the International Space Station and numerous satellites, as solar storms can cause significant damage to space-based technology. If important supply systems on the ISS fail, it can be tight for the astronauts. Stars of space shuttles or supply shuttles are also hampered during the storms. If important satellites also fail, we will no longer be able to receive up-to-date data from space, and our communication systems could collapse. The damage could be enormous. At the moment, no one knows how safe NASA's technical facilities really are. It is a daily tremor and fear at NASA, but also at companies like SpaceX and at other companies and nations that have placed important satellites in space. In October 2024, a shocking event occurred. The sun unleashed an X9.5 flare. This signals the possibility of even more intense storms ahead. Geomagnetic storms at the G4 level could soon become more frequent, and such storms can severely disrupt radio communications and even cause the aurora borealis to appear at unexpected latitudes. To put it simply, the sun operates on an 11-year cycle, starting with low activity before gradually ramping up to higher levels. The number of sunspots increases, solar radiation becomes more intense, and the rhythm of magnetic field reversal changes. The sun's cycles have been known since the late 18th century. The Carrington event was a solar storm of epic proportions and led to intensive research into solar activity and its influence on modern civilization on Earth. The violent solar storm of 1859 paralyzed the still young telegraph network and caused confusion and panic worldwide. The sky burned for days, sparks flew from technical equipment, and people were afraid. The disturbance lasted for days to weeks, and since then, humans have understood the dangers the sun poses to our modern civilization. While animals and plants are likely unaffected by solar currents, electrical systems could experience a collapse. Today, we rely entirely on electricity. If global power grids and satellite communication networks were to fail, it could lead to catastrophe. The sun's influence on Earth will continue to grow. NASA has recently posed the intriguing question of whether heightened solar activity could impact the Earth's global temperature. We are teetering on the edge of a climate crisis, and naturally, people are questioning whether heightened solar activity could worsen the situation. Increased radiation might potentially interfere with electrical systems and satellite communications. However, there have been no observed impacts on the climate so far. The charged particles from the sun that reach us aren't intense enough to significantly warm the atmosphere. Temperatures and weather would most likely remain largely unaffected by violent solar storms. The only things affected are satellites and technical installations in Earth orbit and sensitive electrical systems on Earth. However, experts are still not sure whether solar storms of this magnitude might have a disruptive influence on nature, animals, or even us humans, or whether they might somehow accelerate the greenhouse effect. NASA confided in the best experts of the planet to address this pressing question. The question remains as to how we can protect ourselves. The answer to this can only be not at all. We can't control the solar ejections and flares from the sun, but we can adjust our climate change forecasts and safeguard our electrical systems. Our world has evolved significantly since 1859. Back then, there was only a nationwide telegraph network and the first electricity generators. People hadn't yet experienced the power grid as we know it today, nor had they seen light bulbs, refrigerators, or electricity-powered ATMs in supermarkets. The Carrington event, widely recognized as one of the most intense solar storms ever recorded, serves as a reminder of the potential impact of solar activity. Due to the breakdown of the communication system, it took a very long time for the news of the solar storm to go around the world. In remote parts of the USA, nobody knew what had happened at that time. Mainly the North American continent was affected when sparks flew from the telegraphs and caused fires, and the sky was swarming and bathed in fantastic colors. People thought it was some kind of apocalypse. Only the British scientist Richard Carrington had observed that a dark spot had appeared on the sun before the state of emergency. Carrington correctly combined the two and sent the news of his discovery around. If a storm of the magnitude of the Carrington event struck us today, our civilization would be crippled for days without electricity or functioning communication systems. Chaos would ensue, and no one knows when the sun might unleash such a storm again. It's unsettling to realize that even a moderate solar eruption could push our society to the brink of collapse. The solar particle ejections, like the one in 1859, are a real threat, and we're not prepared for them. Researchers suspect that there have been severe storms like this throughout the history of the Earth. But there were no records, or people at least didn't notice much about them, because there were no electrical devices. Researchers suspect that some very colorful descriptions of the appearance of fire angels in the sky, or religious ideas of a burning sky, may be related to previous violent solar storms. Not even 200 years have passed from 1859 to today, and the sun could produce such storms again and again. Researchers are putting significant effort into documenting and forecasting the cycles of solar activity. However, experts caution against rushing to conclusions. Our observations of the sun have been relatively brief, and despite long-term calculations, we lack a full understanding of the cycles our star may follow. We also don't know if solar flares as powerful as the Carrington event occur in any predictable pattern. Do you ever think about how great it is that our planet has a magnetic field? Probably not. We enjoy the wonder of our home planet and all the luxuries that the Earth offers us every day without even thinking about it. It's only when solar storms or other catastrophes threaten that we realize how vulnerable we are in this world. Our planet's magnetic field is generated within the Earth. The hot molten iron core reacts with the cooler outer layers, and the resulting upwelling friction creates a magnetic field. This encompasses the entire globe and forms centers at the north and south poles. The bombardment of particles from the sun is usually intercepted by Earth's magnetic field, a process that happens naturally. Thanks to this, we can even enjoy the breathtaking northern lights. But what if our magnetic field became overwhelmed or collapsed entirely? That would lead to a serious problem. One thing we do know for sure is that not only would the solar particles impact us more severely, but without the protection of the magnetic field, the sun could likely strip away our atmosphere over a few thousand years, making life impossible. Mars lacks a magnetic field, and as a result, it has no atmosphere. Meanwhile, in our neighboring star system, Proxima Centauri, the exoplanet Proxima b sparked excitement as a potential Earth-like planet beyond our solar system. However, scientists later observed a powerful flare from the star that struck the planet, making the existence of life and an atmosphere there highly unlikely. Subscribe now for more incredible videos to come.